Let us discuss a new concept, that is boundary point. Boundary points means a point which lies on a boundary. Getting? So that means in the simple language we can say it is neither an interior point of A nor an interior point of its complement. I will draw a diagram. See, suppose this is a matrix space XD and this is set A. If X lies on its boundary, then we can call it as a boundary point. Okay, so that means mathematically we can say X is not an interior point of A, it is not an interior point of its complement. Getting? So that means if you draw any ball around X, it intersects A as well as its complement. So that means therefore for every r greater than 0, BXR intersection A is not equal to phi and BXR intersection x minus a, that is also not equal to phi. That means every ball around x intersects a as well as its complement, then we can call it as a boundary point. Okay, let us discuss few examples of boundary points. Before that, I will tell you, we denote set of all boundary points of A is denoted by divide. We denote in this way. Okay, so let us discuss few examples of it. Make a screenshot of this one. Let us discuss few examples. I have considered a metric R du. Du means a usual distance on R. Okay, so our first set A is equal to close interval 2, 3. So we have a close interval here. So it is like this, 2, 3. So it's a closed interval, it contains its boundary points. Okay, so set of boundary points of A, obviously we can say 2 and 3. You can easily tell me. Getting? Since around 2, if you draw any ball, definitely it contains points of A as well as its complement, and same thing is happening for point 3 also. So that's why 2 and 3 are boundary points. Next, if you have this open interval 1, 5, getting? So this is an open interval. If you draw any ball around 1, it contains points of set as well as its complement. So that's why definitely 1 is a boundary point. Same thing is happening for point 5 also. So that's why 5 is also a boundary point. Other than 1 and 5, none of them is boundary point. Okay, if you consider 3, if you draw ball around 3, it does not contain any point of its complement. Getting? So that's why 3 is not a boundary point, but definitely we can say 1 and 5 are boundary points since they satisfy the definition of boundary points. So the next set is a little bit complicated, that is set of rational numbers. Okay, so you know that on a real line there are infinitely many rational numbers and infinitely many irrational numbers. If you take any real number, any arbitrary, rational, irrational, doesn't matter. If you take any real number and if you draw open ball around that real number, then definitely it contains many rational, many irrational. That means what I want to say, it contains contains points of a given set as well as its complement also. So every real number is a boundary point. Getting? Since it satisfies the definition. So that's why boundary point of C is equal to R. Since for any real number, if you draw ball, definitely it contains rational and complement, that means irrational numbers also. So the set of boundary points of C is R. Next is set of natural numbers. So you know that natural numbers 1, 2, 3, 4, 5, distinct numbers we have. So if you consider 2 and if you draw any ball around 2, okay, so 2, which is a member of this set, that means that ball contains point 2 as well as other than 2, 2.1, 2.2, 1.9, 1.8, all these are not members of natural numbers. That means these are elements of complement. So that's why we can say 2 is boundary point. You are getting my point? What I want to say, any ball should contain points of set as well as its complement, and we can call it as a boundary point. So to satisfy that condition, what about 3? If you draw any ball, open ball around 3, is there any element from this set? Yes, 3 is element from this set. And other than 3, many real numbers are there which are from complement. So every open ball around 3 contains points of n as well as its complement. That's why 3 is also a boundary point. Similarly, we can say all natural numbers are boundary points. Getting? But if you select any number other than natural number, suppose 4.5, and if you draw ball around 4.5, there is no natural number in that open ball. So that's why 4.5 is not a boundary point. Getting? So what are the boundary points? So set of boundary points is simply set of natural numbers. So these are our examples we have seen. Make a screenshot of it. After that we will stop. Thank you. Bye bye.